Okay, you've done some stuff on the quadratic formula, and I'm working under the assumption that at this point in your math career, everybody's seen the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And it's probably embedded, and it always works, whether you can factor it or not, whether you can complete the square or not. Anytime you have something like this, ax squared plus bx plus c equaling 0. Whenever you have a quadratic equation written in this standard form, you can always use the quadratic formula and it'll always find the answers for you, okay? And why I've done this is because you'll notice the a is always in front of the x squared, and you've seen this in previous slides. The b is always in front of the x, and the c is always the constant, the number by itself. And I do want to highlight something. Let's say we had 4x squared minus 9x minus 3 equals 0. Okay, make sure as you look through the previous slides that you're very careful with the signs, because a here, a equals 4, b equals negative 9, not 9 but negative 9, okay, because the sign has to go with it. There's a positive, that's a negative, and then c equals negative 3 because the sign has to go with it, okay, so be careful with that. Now what I want to talk about a little bit is the discriminant, okay? The discriminant is this thing right here, right? Because you can only take the square root of a positive number, but there's no guarantee that when I do the calculation that what ends up here is positive. And what's it telling us? I'll just step aside for a second here. Okay. What is that discriminant telling us? Well, it has some possibilities here. Okay. It has some possibilities. So, let me get rid of this. Now, let's just focus on the discriminant. Now, the first possibility is this discriminant is greater than 0. Okay, that works out well. The second possibility is this discriminant ends up equaling 0. And the third possibility is it is less than 0. Okay, because you don't know until you get a specific equation what your values for a, for b, and for c are. So you could end up with values of a, b, and c, notice they're all in here, that make this greater than 0, equal to 0, or less than 0. Okay? Now, if this is greater than 0, you know, you have something like this, you know, maybe negative 4 plus or minus the square root of 28 over, doesn't matter, 14, whatever, right? Right? You will have two solutions, because you'll have negative 4 plus the square root of 28 over 14. You'll have negative 4 minus the square root of 28 over 14. You'll have two solutions. Okay? So no matter what this is, if this is positive, you will end up with two solutions. Okay? Now, if it's 0, then we'll just work up here at the side. What if it's 0? Well, then you're going to end up with this. You know, you might end up with negative 5 plus or minus the square root of 0 over 2. Well, negative 5 plus 0 over 2, negative 5 minus 0 over 2 could be the exact same, because it doesn't matter if you're adding or subtracting 0, it doesn't change that numerator. So, not surprisingly, you would end up with one solution. And in this case here, that one solution would be negative 5 over 2. You'd end up with one solution. Okay. Now the other option is that this thing is less than 0. And if it's less than 0, well, you cannot take the square root of a negative number, right? Which means you would end up with something like this, negative 4 plus or minus the square root of negative 21. We looked at this a little bit, over, I don't know, over 8. And it really doesn't matter, because as soon as this is negative, this is undefined. and your whole solution blows up because you can't add or subtract undefined, and it just means you have no solution, and that's legitimate, right? You may not have a solution. Hey, where's my blue here? Okay, so this means you have no solution. Okay, and that's fine. Not every equation has a solution, because not every equation has an x value that will allow that left side to equal the 0 on the right side. Okay, so that's what the discriminant is telling us. There's a couple other things in the notes that you can look about whether they're rational or irrational, but I will suggest something like this. Let's say this was a positive. Okay, the solutions will be what's called irrational because it's not a perfect square in the square root. Okay, but you can read those. So 2 solutions, 1 solution, no solutions are all possible when you use the quadratic formula.